Let's get started. So for the record, hi everyone. So this is going to be technically a mentoring session that we always recommend you guys to hold. We require these sessions to be at least 40 minutes, 1 hour, at least 40 minutes to 2 hours or 2.5 hours max. We don't expect you guys to take more time than we would in a regular class. So so to demonstrate how we will kind of expect you guys to do mentoring sessions. This is going to be technically 40-minute long, relatively short video. The purpose of these mentoring sessions is to make sure that you guys are ready to speak to the microphone. You guys are ready to speak in front of people who you don't know. You guys are able to take on to a challenge and at least start building it. So for the same with the same idea, with the same spirit, what I'm going to do today is I'm going to go to, first of all, I've opened an incognito window, meaning that there are no cookies, there is nothing saved on the browser. So what I will do is I'll just open a new tab and I will go to CodingBat.com. This is one of the old and proven places where you can practice for technical interview questions. So as you can see, when I open it, there is no account signed in. And what I'm going to do, I'm going to make it a little bit bigger for the record, for the smaller screens to see it better. So no email, no nothing. It's again incognito mode, no cookies, no nothing. And so what I will do at this time is, let me see. I'm going to pick a random one of the tough questions. So we haven't seen map. Functional mapping, we don't do map at this time. Functional filtering, we don't do map at this time. We've seen arrays, we've seen strings. Recursions, we said that recursions are recommended, are highly recommended, but at any point, we believe you are able to solve any recursion questions with loops. So as long as you can build an idea and demonstrate that you are able to easily handle loops, you should be fine. So what I'm going to do, I'm going to take this array 3, harder array. I'm not sure what these APCS medium problems, this is medium. Let me look at what is this. APCS, these problems are based on free response questions on all the APCSA exam. Okay, I have never done this, but we can have another such meeting, and you guys can tell me which of these questions you would like me to go over, and I will happily oblige. I'll happily do so. But I know that array 3 is a harder question. So let's open that up and let's see. Let's click this chance. This chance will open any one of these. And these are technically tough questions. Harder array problems, 2 loops, more complex logic. See the Java arrays and loops document for help. I have done this long time ago, so I'll just take my chances and see what comes up. All right, and so I have an Eclipse open, but I will try to not use it. And what I will do is, we have a lot of white space to our right, so I will make this bigger first. And if I need to make any notes to myself or to you guys, I will make some notes here. All right, so count clumps. Say that a clump in an array is a series of 2 or more adjacent elements of the same value. Return the number of clumps in the given array. So 2 or more adjacent meaning next to each other. I don't know if I'm pronouncing this right. Let's do this. Adjacent. Adjacent, okay. Not adjacent, adjacent, meaning next to, adjoining something else, next to each other, right? All right, so what we have here is, this is basically, these are how technically interview questions are going to look like. They might not give you this kind of a straightforward question. They might wrap this question around, I don't know, real life scenarios. They might say that you will be given stock prices, or you will be given some IDs, whatnot. Okay, so when you see questions like these, what you should do is you should simplify things, okay? So now, the idea behind adjacent is that they should be next to each other. For example, when I look at this test case, it's technically telling us here that if you are given this array, you'll return 2. My assumption is I will return 2 because, let me draw. I will return 2 because there is this one pair, right? 2 2s adjacent to each other, and this one pair, 2 4s adjacent to each other. That's why I'm going to return 2. And in the next example, I'm also expected to return 2 because I expect this one to be 1 and this one to be 2. And this is a very good example. I like this one because this clarifies a couple things for us. One, it's not going to be just 2. It can be more than 2. And the second clarification is that if it is more than 2, you will count all of them as 1. All right. So the trick here is when we looked into this array tree, it told us that there is going to be the necessity to use more than one array, right? So we know that we'll probably need to use 2 arrays, but let's put that knowledge aside. So now let's think about, for example, let me clear these concepts out, right? So let's think about easier cases. Now, we always say during our classes, first thing you do is before you are starting to write any code at all, ask questions. So obviously, I can't ask questions to CodingBat. That's why they're giving us these examples. So my questions would be, what if I have this, for example, right? 2 different values. What if I have the same value in 2 instances, but separated with something else? And what if I have this more than 2 instances of the same value next to each other? So obviously, we have all these questions answered, right? Hopefully. Okay, so the first thing is ask questions. Ask. All right. So second thing is do what? Design test cases. Test cases, right? From simple to tough. But when designing test cases, you will obviously you can use those test cases to design your pseudocode, which is going to be our third step. So from simple to complex, simple test case 1 2 3, nothing next to each other, right? Simple good test case 1 1. So this we should expect to return 1. Another simple good test case 1 1 and 2. We also expect it to return 1, right? Another easy test case 1 1 1. We expect this to return 1 as well. So I'm going to say 1, I'm going to say 1, I'm going to say 1 here, and here we return 0. Okay. Then we go more complex, and this is basically where you go from here on is you look at this case, empty. You look at this case, null. You look at like a single value. This is going to be 0. And we looked at different cases. So then you take these 3 values, for example, and create combinations of it. So you create, for example, a combination of 0, 1, 1, 1. Of course, I forget the commas, and 2. So for example, here you expect to return 1. All right. Now, I remember from old times that what happens is once you design a code and you try to, you hit go, CodingBat will actually test our code against multiple test cases. So we will actually see what we have missed. That's why CodingBat is great, not just for development, but also for testing. Okay. Now, having said that, now let's do this. Let's clear some of these things here. First step is ask questions, put down your notes. Second question is, based on those questions and based on those notes, create test cases and ask the interviewers whether your expectations about these test cases are true. If someone passes an empty array, what are you expecting to get? Are you expecting to get an error, or are you expecting to get 0? If something passes in null instead of array, what are you expecting to get? So do not jump into assumptions. When designing your test cases, ask them, hey, is this a valid test case? Is this a simple test case that I can test on? If the answer is yes, then you say, what am I expecting in this one? So everyone knows that when you have 1, 1, you're expecting 1. You say, is it correct that if I have 1, 1 next to each other, for me to expect 1? So when designing test cases, keep asking questions. Why? Because the answers to these questions will be very important for you to design your pseudocode. Pseudocode. I hope I spelled it right. Okay. Pseudocode, basically, we all know, means that what are going to be my steps before I even start writing the code, right? Now, before we look into the pseudocode, now let's see how our code should behave. Let's take, for example, this one, this test case, right? So these are my elements in this test case, 1, 1, and 2. I have 3 elements in this test case. So obviously I have to loop through elements. And every time I loop through elements, let's say I am at, in my first iteration, I am looking at this guy, right? What do I have to do? First thing I have to do is I need to look at the next guy. While I'm iterating this guy, while I'm pointing to this guy, I need to look at the next guy. Is the next guy the same as the first element, right? If the answer is yes, I create a second pointer, all right? So basically, my second pointer will look at the guy after me. If the second element is the same as my first element, I will say, okay, I found 1. So I will increase, oh, now I need to keep a count, right? Count of matches, count of clumps. I need to keep count of clumps. So I will say, you know what? Right off the bat, my count is going to increase by 1. Why? Because I found a clump. Now, do I stop here? The answer is no. You know why? Because there will be this case. I don't know as code what my next element is after this one, right? So what I need to do is I need to keep going on. So this guy here, now the internal array, that's what we're going to do. The second pointer is going to go to the next one. Is this one the same? If the answer is yes, okay, I will keep going. Okay, delete this and come to here. Now, is this guy the same as the previous one? The answer is no. Right? When the answer is no, what I do, I stop the second iteration because I don't need to have a second pointer anymore. But there is one thing I can do here. When I stop this iteration, can I take this first main loop and put it here? Because I have already covered all this distance, right? I have already covered all this distance. I know that all these 3 are the same and I are a clump, and I have clumped them. So what I will do is, when I stop the second iteration, inner iteration, I will automatically upgrade my main iteration to here, from here to here. So I will not check this guy, because if I check this guy again, what will happen is I will again create a new inner loop, and I'll say, is this guy the same? I'll get 2. Because but that's wrong. I have checked these guys. These 3 guys I have already checked. So I should not recheck them. So this is bad. So I should go automatically here. All right, so having said that, let's now try to create a simple pseudocode. So I'm going to say store loop count, store clump count, right? Because we said, yeah, my handwriting is bad and the mouse makes it even worse. So what we said we're gonna need to do, we're gonna keep the count of how many clumps we're gonna have. Start outer loop, right? Because what we said is we need to create a pointer to the elements inside the array. So outer loop, and what we will do is we will do the following. Start the inner loop within outer loop, right? Start inner loop. Now the inner loop should start outer plus 1 from, I'm going to say from outer plus 1. You know why? Because if my first pointer is here, outer pointer is here, let me make some clear, let me clear something up. So there is a lot of things here, right? So we said that this is going to be my outer loop, right? If my outer loop is here, do I need to check it against itself? No, I can check the next guy, right? So my inner loop is going to start checking the next guy, next element. So that's why my inner loop is going to start from outer plus 1. And here I'm going to have a condition if outer element at I, right, is equal to inner element at Y, for example. This is bad naming. So let's do X and Y because we can confuse I's. So if outer's element at I, at X is equal to inner's element at Y, what I will do, I will immediately count plus 1. And I will now need to do a couple things. One of the things is I will need to now go to the next check, right? I will need to go to the next check. And now what if in this next check, I again have the outer loops element at X, which is 1, is equal to inner loops element at Y, which is also 1. So if I keep this condition the way it is, I'm going to run into a problem. You know why? Because every single time it's going to come check this one and this one, say true. Then it's going to come check this one and this one, say true. And every single time it's going to increase count. This is another trick in this question. That's why this question is tough, right? So there is something else you need to do here, which we forgot when we looked into this. But as we write our pseudocode, it becomes clear that if in the second iteration of the inner loop, we come in and see the element again, our if condition will be true again, and we will be tricked. To not get tricked, what we need to do is, at here, we can create a flag at this level. Before we get into if condition, we create a flag. We know what a flag is. Flag is a Boolean variable, okay? We will say that this flag is going to be called is counted, because if I check these two against each other, and if I've already counted them, I should not count them again. So initially I will say, did I count them? No. In my first iteration, I will say I did not count them against each other. But in my second iteration, this counted should become true. You know why? Because it should become true so that I don't count these again. So in the second iteration, after the condition, if I count something, what I will also need to do is counted should become true. And since I have this flag and I can check against it, guess what else I need to do? I need to add that flag to this if condition. So now my if condition should not only be whether this guy is equal to this guy or this guy is equal to this guy. It should also consider for the case where and they should not just be equal, the counted should be false. And how do we declare counted false? You guys all know. I can say not is counted. If both the conditions are true, which is 1, is this guy in the outer loop, meaning outer loop's element at X equal to double equals, right? Might not like that. You should correct me. Double equals. If this guy's outer loops element at X is equal to inner loops element at Y, right? Then, but before we go count that, then also check if this equality is counted before. If it is not counted, meaning not counted, then count it and update our counted to true. But if it is counted, which will be the next time, again, outer will be 1, inner will be 1. If it is counted, it will not count it again. It will again consider this case, but it will not count again. All right. Now there is now consideration we need to make about how do we once we continue. So 2 questions we need to answer, right? Until when do we continue, right? And how do we stop and bring this outer loop pointer to here? The answer to the first question, until when, is easy. Until the array is array's length. So if you are already at the length, you're going to stop, right? Start inner loop till length, right? Now the second question is, how are we going to take this pointer and bring it to this position, right? To this position once the inner loop is complete. When will the inner loop be complete for us? At a point when we don't have equality. So if, for example, our array was like this, 1, 2, 3. So outer pointer is 1, inner pointer is 2. Are these equal to each other? No. So this loop is complete. And this loop needs to bump to the next one, outer loop. Outer loop is 2, inner loop is 3. What's its name? Are they equal to each other, 2 and 3? No. So the loop is not going to go on. Outer loop is going to bump to next one. All right. All right. Okay. So now, obviously, this answers again our question as to till when the inner loop should continue until the end of the array. Now, how do we bump the inner loops? How do we bump the inner loop's value? Take the inner loop's value and bump it to the outer loop. What we'll need to do is else, meaning if the equality is not there. No, hold on. Yeah. So this is what we will do. Let's not do else, because I will explain you later what the else does. It will do. What we will do is we will say if O of x is not equal to, I think exclamation mark goes first. We'll check. We'll see. Is not equal to I of y. Then what we should do is the x is the outer loop's index, right? What we should do is we should say, you know what, update the x's value. X's value is not going to be equal to, now going to be equal to y. Okay. When we update x's value, we bring this one, the outer loop index, to here. We equal it to 1. And we know that what will happen in the out iteration is when we go to the next iteration of the outer loop, the x will be added by 1 anyway. So it will be 1, 1 plus plus, right? X, we say x plus plus. So x will come here. And outer loop will come here. X is outer loop. Inner loop will try to go to the next one. And it will fail because there is no next one. There is one more thing that became obvious to us. When checking for equality, our outer loop does not need to go all the way to the last element. You know why? Because if it's all the way in the last element, there is nothing after it to check, right? There is nothing, it will throw an issue. So what we need to do is we need to stop at this point. Stop at this point for the outer loop. So our outer loop is going to go till length minus 1. Len minus 1. It doesn't make sense, but if you follow the recording, I mean, the handwriting doesn't make sense, but if you follow the recording, it will make sense. So you know what? At this point, I think there is something else we're missing. Yeah. One thing I said, why do we not want to do else? can you guys stop the recording if you're watching the recording and tell me why we should not do else, but we should do if? Please stop the recording and answer this question, because I will answer it in a second. Simple answer to that question is the following. We have two conditions in this if condition, right? One, we're checking if the outer loop current element is equal to inner loop current element. Okay, that's perfectly fine. But we're also checking for is counted flag, right? So what will happen? What do you think? If I take this first element and compare it to the third element, this if condition will become false, even though 1 is equal to 1, our is counted is false now. That is why what will happen is this if condition will become false, and what will happen is we will else condition would be this, right? X is equal to y, and by the way, we need to break from here. Once x is equal to y, we need to break. We don't need to continue our loop anymore. If 1 is if 1 is equal to 2 is not equal to 2, we don't need to continue our inner loop, right? Why are we going to go check and further anything further, right? So that's why if we put else here instead of separate if, what will happen is this else will fire the second time right here. And if we have a case where we have another one here, what will happen is we will technically not count this, because our condition will fail here. Our else condition will fail here, right? Now, if you have made up to this point in your interview, it doesn't matter. It took you, I believe it took me 20 minutes to come to this point, right? I don't have a timer, but I should. Okay, it took me not even 20, maybe more minutes to come here. It's okay. Even if you took so many minutes, I mean, of course, in the interview, you will not take so many minutes because I'm thinking out loud and I'm explaining myself and stuff. But again, do take so many minutes in interview. If they tell you, you know what, you want to go ahead and write a code, stop there, say that, you know what, yeah, I will write the code now, but we probably will need to go back. We'll need to come back, right? All right. So, but what my point was is that if in the interview you write all this pseudocode, you walk them through all of these cases, all of these conditions, you brainstorm, you show them that you understand what will happen if this goes on or the other thing goes on. Believe me, you got the job. Okay. And sometimes they will say, you know what, can you put it to the code, simply because they want to see if you know Java the way you say you claim you know, right? They would just want to see what your syntax is. Okay. Now, long story short, let's do this. So with this pseudocode in our hands, it's easy for us to now code. First of all, you know why we're returning -1, but we don't need to return -1 in this case, simply because we have this item here, store clump count. Okay, int clump count is equal to 0, right? And return immediately. We have a public int method, meaning this is a value method that returns int. So we immediately, that's why we need to store clump count as int. If they ask you that question, hey, why int? Why don't you store it as a byte? Say that for the simplicity, I will store it as an int because this returns as int. So I will just return clump count. By the way, you can perfectly store it as byte. The system, Java compiler will automatically cast it for you. Casting from smaller to larger is perfectly fine. If you're casting from larger to smaller, that's where you run into trouble. Outer loop for x is equal to int x is equal to 0. And if they ask you why int here, not short, because tell them that my x will iterate from 0 all the way to the num's length -1. From the above examples, we know that the length is going to be 5 or 6. What if someone wants to load the system and send a nums array that has, I don't know, more than 2 billion values? Is that never going to be the case? or actually not more than 2. I'm sorry, more than like short is what, 65,000 characters? Yeah, 65,000 values. So what if someone sends an array with 200,000 elements in it? My short would fail. So that's how you reason, right? These questions are very good questions, and do not like become defensive or anything. Think about them, all right? Because I just thought about it, like, if, since I said this short, this can be short, why not short? This can also be short, why not short? Okay. All right, so we talked about why we want to go up to length -1, simply because we don't need to take the last element and check it against anything else. We need to take element before last, right? Now, the problem is, when we say length -1, we are dealing with indexes. It should not be length -1. Length -1 is actually the last character, last element, right, in the int array. So we actually need to do length -1 -1. Okay, so length -2, because we're going to stop at the last second from the last element. Okay, now when we have a case like this, before even we continue, and this was not part of the pseudocode, for us to go through an array and go through its length -2, think about it. What if someone passes in an empty array? What if someone passes in an array with a single value? What if someone passes in an array with 2 values? And then 3 values, for example, right? Now, when we say length -2, we will take empty array and take 2 steps before it. Not possible. When we say length -2 to an array with single element, we will take the length, which is 1, -1, which is 0. This is okay. -1, which is -1. This is not possible. So the only time this length -2 will work is if the array has at least 2 elements, because length -2 is, this is length, which is 2, -1, which is this position, -1, which is this position, right? So what we need to do at this point, we need to stop and say, if num's length is less than 2, return 0. If it doesn't make sense, please stop the recording, go 15 seconds before we listen to the explanation one more time. And while we're at it, if length is less than 2, we should also, as good developers, we should also do this. If nums is equal to null, or nums length is 0. I was thinking about something else. Return 0. What are we doing here? We are answering these questions. The case where the array is empty, the case where the array is null, the case where array is a single element, right? And when we look at these 2 if conditions, what we're going to say is, you know what? Let me check the length, the array being null here. And why do I need to check for the array length 0? Because I have a condition already here saying that arrays length less than 2. So let's do this. Let's just take this condition from here, put it here. Okay, and return 0. We don't need this condition anymore. Why we do that? Because this simple single if statement will return 0 and will not go into all this lengthy calculations. In the conditions where our array is empty, our array is null, basically null check should be before. If you are trying to check a length of an array that is null, you will fail. So null check should always be before. So we're checking for a null condition, we're checking for all the other conditions where array is empty, array has 1 element with this condition. Okay. All right, we already are making progress. If I run this code right now, it will pass some test cases. Did you know that? I'm not going to do this. But if you want to open this, pause the recording, open this question, put this code in and run it. I don't want to run it now because I want to see if I will be able to run it from a single, have a happy path, have all my tests pass from a single run. Anyway, let's continue. Now we said outer loop is x all the way until starting from length -2, and we consider the cases where length might be less than 2. Let's look into our inner loop. For int y is equal to, we don't need to start from 0, right? We said we will start inner loop from outer +1. So x + 1. Perfect. Y will also go till nums length -1. Okay, but give me a second. Let me think. Nums length -1, it will go until there. Nums length minus. Actually, I made a mistake. This should be -1 because we are having. Oh, where is my condition? X less than nums length -1. Yeah, because we have a hard case, hard less than, we don't have equal to. So -1, it will be where like arrays 3 elements. 3 - 1 is 2, right? Here, this third. We will say it will be less than 3 - 1. Less than this is, it will only check this value. It will check the index element at index 1. It will not check the element at index 2. So this is right now. Yeah, we correct ourselves. So the outer loop will go arrays length -1. Inner loop will go arrays length inner loop ++, right? Always increment our values. Now the question comes, let's actually, before we ask questions, let's put some code to practice. If the nums element at x, which is the outer loop element, right, is equal to nums element at y and not is counted. Let's put this code first. What we will do is we'll say clump count ++, right, and is counted is equal to true now. Now, two questions. Actually, one important question: where should is counted go, and when should we define it? We can only check for inside the inner loop. Is counted should only be turned true once, and every single time we go out the inner loop, we should turn the is counted to false, because next time, if we do not switch is counted to false at all, after it's switched to true, we will never be able to count other clumps. So what we need to do is the flag will go before the inner loop starts, and it will start from false. Our flag will not be up. Okay, and the moment we find the equality, we will count our clump and we'll raise our flag. Once we're done with that, we will have our second if condition. If nums at x is not equal to nums at y, in that condition, we will first of all update x so that the outer loop comes up to the position where inner loop was, and break the inner loop. Now, since we know break, we also know continue. If we have found this case where these values are equal to, do we need to get out of this if and check for other if? No, we don't. That's why we can also add here continue. All right. Is there anything we're missing? I think this is about it. Let's now remove some spaces and see if we have a complete vision. Can we make this bigger? No, we can't. Okay. Editor font size 100%. What is it? Shorter output? No. All right. So now what did we do? What we did is the following. We checked for the edge cases, right? Null and length cases. We have outer loop, which will go until the last element. There's going to be a flag, is counted flag. We have inner loop, which will start from where the outer loop is +1, and will go until the length of the array, nums array. and it will say that if current nums element in the outer loop is going to be our outer pointer, right? The pointer on the right. If that the value that pointer points to is equal to the value that the inner pointer points to, meaning the next element, and if it has not already been counted, then increase the count and update the counter to 1. Update the counter to true. Yeah, 1 is also true, my bad. So update the counter to true. And then, you know what, forget about the rest of it. Next time, if it is equal again, but this time we will also check for the counted, we will skip. We will skip until, so basically next time, this condition will be false, meaning this whole thing will be false. Since this whole thing will be false, it will come here and check if they are not equal. So this will not be harmful. It will not be harmful because if they are equal, we will not do this. At any point where we find out that the outer array's current element is not equal to inner array's current element, will break. Perfect. Hit. Go. Compile problem. This is good problem to have. Cannot find symbol clump count. Line 14. Oh, I made a typo here, sorry. So this is not clump count. All right, perfect. All right, again, my goal is to achieve single time run and having everything pass. I have my fingers crossed. These kind of a compilation issues, these are perfectly fine. In the interview, if you have something like this, it's perfectly fine. Every compiler will tell you where the code is wrong. If the compiler doesn't, please do feel free to ask the interviewer, what am I missing? Because interviewers will be helpful, understanding that you might be anxious, you might be a little bit excited. So the compilation issues are not a problem. If they tell you, look at this line, that's going to be your job to find the issue in that line. But they should be able to tell you, right, where you're making a mistake. If they don't tell you, it kind of raises some questions about, you know, the team, because technically there's supposed to be teamwork here. But this is perfectly fine. So even if you don't find a mistake, it's perfectly fine. Don't worry about it. So our fingers crossed, everything will go green. Run. Aha, we have a failure. Why? In this case, we were expecting 2, but we got 1. All right, now let's clean all our drawings and focus on the conditions. Clear all drawings. So in this case, we were expecting 2, but we're getting 1. There is something wrong. So in this case, we were expecting 2. We're getting 2. In this case, we're expecting 1. We're getting 4. All right, you see, there is something wrong with our conditions here. There's something wrong with our counting conditions here. Now I need to think about it. I think, all right, so the outer loop goes through every single case. And then if it is not equal, oh, you know what's the problem? So when we're checking this not equality, we are bringing the x to y and we're breaking the outside loop, right? Now the question is, I think the problem is with the last element. The problem is with the last element. So we are going to bring the x to y, right? What are we missing? What are we missing? If we make the x as y, x should be less than num length. So if they are not equal, all right, so let's do this. In this case, I want to look into Eclipse to see what we are getting. I want to put this question into Eclipse to see what we're getting because I'm having a difficult time seeing what the problem is. And is not counted. Okay, so false will be true. We will add clump count. We will update the clump count. We'll update this counter to true. But why are we getting 4? So we're checking this guy against this guy. Okay, then we're checking it against this guy. Then we're checking against this guy. Then we're checking against this guy. And we are saying that x is equal to 1. X is equal to y. Oh, I see what the problem is. Yeah, here you go. So what's happening is we are only updating the x's value if we run into a case where our elements are not equal. Okay, so what's happening here is the following. So we take this as outer loop, right? So let's look, let me draw again. Yeah, I think I found what the issue is. So this is our condition that is failing, right? What's happening is, let's say we're in this outer loop. Our inner loop starts from here. Count is updated by 1, right? Because of this condition. Then what we're saying is in next run, we are checking for is counted is true, so this becomes false. We're checking for whether they're equal or not. If they're not equal, we are updating the value and breaking. But they are equal, so we're not updating the value. We're going to the next guy, we're going to the next guy, we're going, that's it. So this value never gets updated because we're only checking for the last. We're only checking for not equality. So what we also need to check is if we have already hit the end. So meaning, like, we looked at the first guy, this guy is the same, 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 right? So if we have already hit the end with the same guy, we should completely break. Okay, well, we can still use this condition. If we say x is equal to y, if that gets updated, we're perfectly fine. So let me do this. Let me delete. Let's try what we said. So, okay, hold on one sec. What is our eraser? Here we go. So let's do this. Now let's update this condition with or y is equal to nums length -1. Y is already at the end. If the y is already at the end, do this and break. Run. All right. So we fixed this case. But why is this case failing? So I know this is being captured, but this is not being captured. So nums length -1. Okay, we're taking this element, the 4. And if they are equal, continue. Add 1 and continue. Okay. So this guy is equal to this guy, but why is it not checking it? X plus 1. Okay, so it is checking it, right? So it's starting at 4. X is here. Y is here. If they are equal and is not counted, add 1. Then why are you not adding? Very interesting. Why is it? What am I missing? Was I supposed to do length -2? Okay, so let's look at this. So length is 3 up all the way to 2. Yeah, I was supposed to do length -1, -2, I believe. Yeah, my first idea was right. And this guy will go. No, I don't think so. No. This is length -1. So there is something I'm missing. So let's look at this clue. Here we're returning 5. I'm sorry, we're returning 3, but we're supposed to return 5. Why are we returning 3? So these guys are working This is working. This is working. This is not working. I think there's something wrong here. Yeah, let's put this to Eclipse and put these test cases. This is a very good question. I like this question. So let's put these test cases into action. By the way, if you get to this point and you get stuck in the interview, if the time is up, it's still okay. You'll do better than 95% others. But of course, it would be good to solve it. If you did solve it, you would definitely get the job. But now you have 95% chance. So let's do this. Mentoring and class clump count. So did I copy everything? Let me do that again. Control A, Control C, come up here and put it here and create your main method. And let's bring this array. Let's actually take this. Here we go. Which one is failing? This guy. Here we go, right? Copy, put it here. And to get the idea, if I run it now first, so the reason why it's not running like this is because it is not static. Since it's not static, it's requiring the object of the clump count class. If we make it static, it should run just then. Oh, and another thing is this guy. New int array like this. Okay. Yeah, we need to define our int array correctly. All right, if I run this, we're gonna get, come on. How am I gonna get it? I need to print it. This is again the first run. I want to see what's happening. It will give me 1, right? Now to understand why it is giving me 1, we need to add some print statements. To add the print statements, let's do this. Inside the inner loop, yeah, let's use shortcuts. We don't have much time. We're gonna say this x is equal to x and y is equal to y. There's a plus sign missing here. Okay. And what else do we need to do? Let's add a print statement here and say first if, and let's add a print statement here and say second if. Now when we run it, it will tell us where it is stopping. X is equal to 0, y is equal to 1. Second if x is equal to 2. Oh, it is skipping. Oh, yeah, it's skipping. You see, yeah, this was the issue. The issue here is it is skipping one step over because y becomes 1, right? And then x does not start from 1. X is supposed to, if they are not equal to each other, now it makes sense. This is why it's important to have visualization. So let's do this. We have 1, 2, 3, and let's start from 0 to make indexes easy to understand, right? Let's say outer loop is here. Inner loop starts from here. What we do is, in this condition, we're saying, bring the outer loop to here. But the problem is when this condition is over, it breaks the inner loop, it goes to the outer loop. In the outer loop, we're adding one more. So it becomes here. It does not check this one against this two. Yeah, that's the problem. So what we need to do is we need to say y minus 1. And now if we run, we will get 2. Yeah. It's you see, small issue, but can cause you a lot of headache. Now we're good. Now we're good. In the interview, hopefully someone like usually when I am on the other side, when I am taking interview, when I see issues like this, I tell them, I point them out because it is very tough for a candidate to recover from this point. You know, it's very tough for a candidate to have all this to write all this code with all the analysis and stuff like this, and then a small mistake we made, right, and then hit this, and then candidate sees, oh my god, what happened. It's very tough for a candidate to recover. The only way to recover is to have the ability to add these print statements and analyze what's going on. Some interviews, you will definitely be given an IDE like this instead of CodingBat. CodingBat does not, I don't know if it prints stuff. Does it print stuff? If it prints stuff, that's perfectly fine. Difficulty what? Difficulty 327. Oh my god, wow. All right. So if it prints stuff, let's bring in these print statements and see if it will print them. I don't think so, but let's still try. We did it here, right? Yeah. Bad code. Don't call print, computer return result. Yeah. Obviously, you see we can't call print. So if you can't call print, it's very tough to understand what it is that we're missing. All right. So that's why if you are able to solve, please do solve on the CodingBat. Have your hands get used to it, and have you come into these kind of issues where it tells you there is an issue on line 8. So go to line 8, 1, 2, 3, 4, 5, 6, 7, 8. What is the issue? Int x, num's length. Find this issue. Get used to it. So do not immediately take the question to the Eclipse. But if you have something like this, that's when you will need to take it to Eclipse, because without print statements, without debugging, that's what it's called. Without debugging, it's impossible to really see this small issue. Maybe possible, but obviously it was not possible for me. Run, we could. So we had the right idea. We had the right idea. Even if you remember in the beginning when I was talking about making them equal, so it does start from there, I was incorrectly thinking that it will, for example, we stopped y here, right? We stopped y here. I incorrectly pointed x to here as well. And I even said that x will be updated as 1 because I thought x will be here and it will go to the next one, right? But the problem is, if they are not equals, for example, if 3 is not equal to 4, the outer loop will be coming to this 4, and then it will be added one more. But it's wrong. It should not be skipping one step. It should be stopping here. So I should say that, hey, you know what? Stop the x here. If 3 is not equal to 4, say that x is not equal to y minus 1. Y is 4, right? Y minus 1 is this one. So that then in the outer loops iteration, the x plus plus is going to put it to the next step anyway. So now it will start at 4 and look at the next guy. So this is basically perfect example of what can go wrong in interviews, even though you have everything perfectly set up. If you run across something like this, tell them that I need to be able to debug to understand what's my problem. I think it is somewhere here or somewhere here. It's one of these conditions and calculations. I'm missing it. I can't see it. The only way to see it is to be able to debug it. I don't know if, for example, we're able to log high. I don't know how, for example, CodingBat works. Does not log, right? So what about logger? I don't know. So these are tools used in debugging, right? So you tell them that, you know what, I need to be able to at least write a print statement to see what the values are. Because if I see something like this, I will understand that X is skipping, right? If, for example, before this Y minus 1, when we executed this, we could see that X is skipping a step. It's starting at 0, or then it's starting at 2, then it's starting at 4. You see? So X is skipping, missing a step. All right. So having said that, I hope this serves as a good example of what you should do in these mentoring sessions. Don't do like, you don't have to do like what I did today. You don't have to come to the toughest part and create a go for a chance, right? Do that. It is definitely encouraged. You don't have to be able to fix it in this 45-minute session or 1 hour session, right? But attempt counts. Being able to recover counts. All right. So you failed it. That's perfectly fine. Are you able to put your senses together, put your emotions together, and go back and recover from that? That's the most important part. Believe me, we have hired, like I've seen a lot of candidates being hired just because they were able to demonstrate recovery. They failed miserably in a simple question, but they did not just get stuck with that failure. They did not tilt. They recovered. All right. So if you can demonstrate this recovery, believe me, you are going to get the job 100%. If not, there is something wrong with the team. Good. It's good that you didn't get the job. But again, if you recover, you will be able to get the job 100%. Right. Having said that, I will complete this demonstration. Thank you very much for watching. If you're part of classes, you're lucky. If you're not part of our classes, please feel free to reach out to us. We can do more of these sessions per request. And we encourage you guys, everyone, especially our students, to please come up with questions. Let's sit down and solve them together. Learning is about making mistakes and learning from mistakes. And the best way of that's a very good way of learning. That's the best way of learning, by mistakes. And there is a better way of learning, is by trying to help others understand, see what the mistakes are. Now that I have seen this, I have done this, believe me, I will never forget this. Especially because I tried to explain you the route, and I realized what the issue was, and I explained the issue. I will never now forget this issue. Again, thank you very much. See you in our next recordings.